Hello, this is Shaban Acharya again. In this video, I'll do the homework from sampling distribution of sample proportion, and the previous video about sampling distribution of sample mean. This is about the proportion. Okay, so here the first question. Complete the sentence below. This is a definition question, and again, I want to tell you the sample proportion is gonna denoted by p hat. We read as p hat. Okay, and the formula for sample proportion p hat equals to x over n, and x is the number of individual with the specific characteristics. Okay, x is the number of individual with the specific characteristics. N is the sample size. N is the sample size. Sample size. How many sample you draw from the population, that's the sample size. So here you got to fill in the blank here. The sample proportion, obviously sample proportion, the sample proportion, sample proportion donated by p hat is given by the formula p hat equals to x over n. So make sure that you choose the right option from drop down menu. So that's the answer for question number 1. Question number 2, true or false? The population proportion and the sample proportion always have the same value. That's false. Remember that population proportion is the p, sample proportion is the p hat. So p and p hat is not going to be the same value, no. But what is the same going to be mu p hat is same as p. This is called mean of the sampling distribution of sample proportion. Mean of the sampling distribution of sample proportion. That's is same as p, not p as same as p hat, but mu p hat is same as p. Notice this is subscripts together. It's not like mu times p hat. Don't write this way. It's going to be mu subscript p hat, which is mean of the sampling distribution of sample proportion, which is same as population proportion p. Alright, question number 3. Okay, so in this question, you got to use the applet, sampling distribution applet in MyLab Math. I don't think I'm gonna do here applet in this question. So you try yourself in MyLab, and when you try, make sure that you read this instruction carefully. Okay, there's instruction here, very longer paragraph here. Okay, you got to read this very carefully to answer the part A. Also, you need to answer the part B. You got to read this part B carefully, again, and follow the applets, and so you should be fine. And also to answer the part D, you read this carefully, and it tells you change sample size to 60 1,000 times. Make sure that you read all the instructions carefully to answer these questions. Okay, so I should say you should finish yourself in MyLab's applet. I'm going to do question number 4. Fill in the blank to complete the following statement. For the shape of the distribution of sample proportion to be approximately normal, it is required that the np1 minus p greater than or equals to 10. Notice that this is the criteria for sampling distribution of sample proportion to be normal. Okay, there's 2 criteria, by the way. The one criteria is going to be np1 minus p greater than or equals to 10. Other criteria are going to be n is less than 0.05 of n. So uppercase n here is population size. But this question asks you only one criteria. For the sample shape of the distribution of sample proportion to be approximately normal, we require the np1 minus p greater than or equals to 10. Part B. Suppose the proportion of population that has a certain characteristics is 0.75. So this is population proportion. So 0.75 here is P. Okay, again, because the 0.75 is a proportion of the population. That's the population proportion. The mean of the sampling distribution of P hat from this population is mu P hat, that's the symbols, which is same as P, which is 0.75. Why? I just mentioned before in question number 2, you notice that mu P hat is P. So here you are given the P value and you are asked to find what is mu P hat. In other words, what is mean of the sampling distribution of sample proportion, which is same as 0.75. Part question number 5. Suppose a random sample of n equals to 200 teenagers 13 to 17 years old was asked if they use social media. Of those surveyed, 153 state they do use the social media. So here 153 is number of individual with given characteristics. Here x equals to 153. Out of n, how many? 200 say they use social media. In other words, how much percentage they use social media, that is called sample proportion. So here the formula P hat equals to x over n. X is 153 divided by 200, and we use the decimal 0. Let's see what's that going to be, 765. Okay, 765. That's the population sample proportion, 765. Okay, question number 6. There is 3 part here, but I just do only 1 part because other part is similar, just change the sample size. So part A here, n equals to 4000, and consider the sampling distribution with P equals to 0.09. Here P value going to be 0.09. That's the population proportion. Using the appropriate formula, find the mean and the standard deviation of the sampling distribution of sample proportion. You're looking for 2 things here. One is a mean, other standard deviation. So first part A, you put the what's the mean going to be here and what's the standard deviation going to be here. You don't round the mean, you write exactly the mean, whatever you get, but the standard deviation you round it to 4 decimal places. So let's find the mean here. So mean is mu P hat, which is same as P as a formula, and sigma P hat is P 1 minus P divided by n square root of that. That's the standard deviation of the sampling distribution. So this question asks you to find these 2 values. So what's the mu P hat? That's the mean. It's same as P is 0.09. So this first question answer is going to be 0.09. But the standard deviation, you got to put the value of P and n. 0.09, 1 minus 0.09 divided by n value is 4000 here. Okay, and square root of that. And I suggest you put everything in the calculator once and you rounded your answer to the 4 decimal places. This is going to be 0.0045. That's the standard deviation of the sampling distribution of sample proportion. 0.0045 is the standard deviation. The part B, the mean is exactly the same, 0.009, but the standard deviation, you do the exactly same calculation. You just put 4000 as 1000. Similarly, you do for part C. Okay, so again, I already did for you. I'm not going to do now, but I'm going to write the answer for the each one. So for part B, 0.09 is going to be the mean, exactly same as P, and the standard deviation is going to be 0.0090. For part C, mean going to be again 0.09. The standard deviation is going to be 0.0181. And what you notice here, let me write this way, okay? So this is for this standard deviation is for n equals to 4000. This standard deviation is for n equals to 1000. The standard deviation is for n equals to 250. So remember that mean is the same, but the standard deviation of the sampling distribution is different. So what you notice here is if you increase the sample size to 50, 1000 to 4000, what happens to the standard deviation? Watch here. Put the arrow down here. So this tells you as you increase the sample size, you see the standard deviation get smaller, 0.01, 0.009, 0.0045. So this is going to be decreases as you increase the sample size. So you choose the answer here. So as a standard sample size get larger, the standard deviation gets smaller. That's the answer for last question. As the sample size get larger, right, the standard deviation get smaller. In other words, if as the sample size gets smaller, standard deviation get larger. You can see other way around. Okay, that's the answer. Like an inverse relationship. One increases, other decreases. I could say that one increases, other decreases. Okay, one means as the sample size increases, standard deviation decreases, and vice versa. Question number 7. Describe the sampling distribution of p hat, a sample proportion. If the question said describe the sampling distribution, you got to do three things. You have to verify the criteria for sampling distribution of sample proportion to be normal, and also you got to find mean of the sampling distribution and the standard deviation of the sampling distribution using the formula we just used before, right? Next previous question. So let's verify the two criteria for sampling distribution of sample proportion to be normal. The first criteria is NP 1 minus P greater than or equals to 10. And other criteria is N is less than 0.05 of N. You could have less than or equals to. So let's verify. What's the lowercase n here is 700. P gonna be 0.6. 1 minus 0.6 greater than or equals to 10. And if you put this in the calculator, you simplify, you get 7, you get, see, 168, okay, is greater than or equals to 10. So first criteria for sampling distribution of sample proportion to be normal satisfied. The second criteria, you use n less than or equals to 0.05 of uppercase n. The n again is 700, is less than or equals to 0.05 of uppercase, and here is given at the size of the population, which is 15,000, and you do 0.05 of 15,000, that gives you 750, and less than or equals 700. So this is also true because 700 is less than or equals to 750. That's both criteria satisfy. So if both criteria satisfy, we can call sampling distribution of sample proportion is approximately normal because this true criteria satisfy. So you ignore this not normal criteria. So let's see. I think this took part A is the answer. Approximately normal because n is less than 0.05 of n, and np 1 minus 3 greater than or equals to 10. Okay. Now, since sampling distribution is sample proportion is approximately normal, you got to find the mean and the standard deviation of the sampling distribution. So mu p hat is the mean of the sampling distribution of sample proportion, which is same as phi. And what's the value of phi? We have it before. The value of phi is going to be 0.6. You see here, it's going to be 0.6. This is going to be 0.6. Now, sigma p hat has a formula. Phi 1 minus p divided by n, everything square root. So let's put the value 0.6 1 minus 0.6 divided by n is 700, and find the square root of that, and use the calculator and round it your answer to the 3 decimal places. This gives you 0.019. okay, this is going to be 0.019 is a standard deviation of the sampling distribution of sample proportion. Okay, question number 8. Describe the sampling distribution of sample proportion, assuming that population is 25,000 and n equals to 300, lowercase n equals to 300, p equals to 0.30. Again, it's exactly same as question 7, so you finish yourself, because that's exactly the same question. I should say exactly similar questions. Okay, question number 9. Again, this is again similar to question 7 and 8, because the question actually described the sampling distribution of p hat, sample proportion. Assume that the size of the population is 30,000. This is the n, uppercase, and lowercase n is 1200. P equals to 0.059, and you do exactly same as we did in question number 7 and 8. You check the 2 criteria to be normal, and next to you got to find the mean of the sampling distribution of sample proportion and the standard deviation of the sampling distribution of sample proportion. This is same as question number 7 and question number 8, so you can finish yourself. Oh, I should say similar as question, not exactly the same, but similar as question number 7 and question number 8. Okay, question number 10. So question number 10 is going to be pretty much similar, but except you verify the criteria and find this mean and the standard deviation. You got to find the probability as well. So let's do question number 10. Suppose simple random sample of 75 is obtained from the population whose size is 20,000. Lowercase n sample size 75, uppercase n population size 20,000. Whose population proportion with the specified characteristics is 0.6. That's the p. Population proportion is 0.6. I should say 60%. Complete the part A through C. So part A, you got to describe the sampling distribution. Again, describe means you verify the criteria for sampling distribution to be normal, and you find the mean and the standard deviation. And we need that mean and the standard deviation for next part. So let's verify the criteria. NP 1 minus p greater than or equals to 10. Let's do this criteria first. And 75, p 0.6, 1 minus 0.6 is greater than or equals to 10. And if you put that in the calculator, let's see what you get. This whole thing in the calculator gives you 18 greater than or equals to 10. So it's verified. First criteria. Second criteria is n is less than or equals to 0.05 of uppercase n. So n here is 75 is less than or equals to 0.05 is of uppercase n is 20,000. So obviously 20,000 of 5%. Remember, this is the 5%, okay? 20,000 of 5% is obviously greater than 75. That's definitely true. Even you multiply 0.05 times 20,000 and see is that bigger than 75 or not. It is. So this is true. So these two criteria are satisfied. So two conditions satisfied, I can say that. Condition satisfied. So we can say that it's normal. I can choose approximately normal because these two criteria satisfy, which is D here. Okay, you got to see the option, correct option. We don't say normal, we say approximately normal because two criteria satisfy. So now mu p hat is same as p as a formula, which is same as 0.6. 0.6 here. rounded to 1 decimal places as needed. So standard deviation is going to be sigma p hat equals to p 1 minus p divided by n square root of that. So p is going to be 0 0.6, 1 minus 0 0.6 divided by n is 75 square root of that, and you round it to 6 decimal places as needed. So you got to follow the instruction. The 6 decimal is going to be 0 0.56569. So this is the standard deviation of the sampling distribution of sample proportion. So next question is, what's the probability of obtaining 51 or more individual with the characteristics? That is, what is p hat equals greater than equals to 0.068? Okay, it's basically asks you probability of obtaining 51 or more. This is basically saying p of x greater than equals to 51. But notice that this is the probability of x greater than equals to 51 is same as probability of p hat greater than equals to 0.068. Sorry, 0.68, because p hat equals to x over n. Here x is 51 divided by 75. That gives you 0.68. So if you use the calculator function to find the probability using normal CDF, we use 0.68 as one of the bound, not 51, because 51 is a number of individual with characteristics, but we have to use the sample proportion. So 51 out of 75 is same as saying 68%. So I use 0.68 here. So I'm looking for probability of p hat greater than equals to 0.68 rather than probability of x greater than equals to 51. So if you are using this probability, I use normal CDF, and since you are greater, so greater means to the right, and this number is going to be 0.6 is going to be lower bound. So upper bound we use 10 to the power 99 as usual, because we don't know what's the upper bound is going to be because we are in greater direction, right? So the mean is going to be 0.6. Remember that this is mu p hat. That's what we found in this question here before. That's the mean, and the standard deviation is going to be 0.056569. That is here. Okay, that's here. So if you use this in the calculator as we did in the last section, use normal CDF function, and you put these 4 numbers together. Again, these 4 numbers, first one is lower bound, upper bound, the mean, and the standard deviation. Obviously standard deviation comes from this formula, we had it before, and you get the probability around your 4 decimal places. Read the instruction carefully. So you're going to be 0.0787. that's the probability obtaining x equals to 41 or more. Okay, all right. Part B is similar. You're looking for probability obtaining x equals 36 or fewer. Okay, previous question it was 51 or more. Let's see that. Next question you got is 36 or fewer. 36 or fewer is same as saying probability of p hat less than equals to 0.048, because p x less than equals to 36 is 36 or fewer. Okay, 36 or fewer. This is same as saying p hat less than equals to 0.48, because p hat equals x over n. If you want to change 36 into the proportion, you do 36 divided by 75 sample size n, which is going to be 0.48. So now since you're looking for the probability, we use normal CDF function as we did before, normal CDF. So now since this is less, but this must be upper bound, and by the time lower bound is going to be negative 10 to the power 99, comma 0.48. That's the upper bound because of less. Mean gonna be same as 0.6 as before. This is the same mean we're gonna use because you have the same questions. And the standard deviation is gonna be 0.056569. Okay, so if you put this 4 number in the calculator as we did in the previous section, and you get probability of x less than equals to 36, or probability of p hat less than equals to 0.48, and the value here is equals to, again rounded to 4 decimal places, and you get 0.0169. Okay, question number 11. This is similar to the question number 10, similar, but I will skip how to check the criteria because we already did it. So here is n equals to 1000, and uppercase n equals to 1 million. So by checking those two criteria, you see that the sampling distribution of sample proportion is approximately normal, and use the formula, which formula we had before. Mu p hat is same as phi, and sigma p hat is same as n, sorry, p 1 minus p divided by square root of n, and you're going to find the right answer here, which gonna be C. Okay, again use the formula. We already did the one for you before, so it should be fine. This is the standard deviation, you'll get it, and the mean gonna be 0.48, which is same as p. Okay, so now let's do the probability. What's the probability obtaining 620 or more? It's like before. We have, remember that you have the number like x value, you got to change the proportion. Same thing here, you have x value here, you got to change the proportion. So for a p hat equals to 620 divided by, what's the sample size? Sample size is, let's see, sample size is 1000, right? This is going to be 0.62. So the first question, you're looking for probability of x greater than or equals to 620. This is same as saying probability of p hat greater than or equals to 0.62. Okay, so since you have a greater, as you know in previous question, is normal CDF. Lower bound is negative 10 to the power 99. Upper bound is 0.62. The mean gonna be 0.58. The standard deviation is gonna be 0.0156. That's from here. And if you use the calculator like we did before, this gives you the probability round to 4 decimal places is gonna be 0.0052. Okay, so for the next one, for C is similar. P hat for the 550 going to be 550 divided by 1000, which is going to be 0.55. So now probability of x less than 550 is same as saying probability of p hat less than equals to 5.55. So you have a less here, so this is going to be upper bound. So use normal CDF function, normal CDF, negative 10 to the power 99, 0.55. The mean going to be same as sampling distribution mean, 558. The standard deviation going to be same as 0.0156. Again, this value here, the mean standard deviation, comes from the sampling distribution mean and the standard deviation. You have to use that. So if you use a calculator, you get 0.0276. That's the probability. Question number 12. According to the study conducted by statistical organization, the proportion of the people who are satisfied with the way things are going in their lives is 0.84. So this is going to be population of the proportion, okay, who satisfy with the way things going in their life. So here p equals to 0.84, that is given. Suppose the random sample of 100 people is obtained. So sample size is 100. We call n equals to 100 sample size. Complete part A through E below. Part A. Suppose the random sample of 100 people is asked, are you satisfied with the things are going in their life? Is that response to this question is qualitative or quantitative variables? Obviously, the response of these questions, are you satisfied with the things are going in your life, is going to be yes or no. So that must be qualitative variables. Qualitative. So answer could be one of those. Let's see which one is the correct. C is the correct answer. The response is qualitative because the response can be classified based on the characteristics of being satisfied or not. So this is the answer for part A. The part B. Why the sample proportion p hat is random variables? What is the source of variability? So sample proportion is random variable because sample proportion varies from sample to sample. In other words, one sample has one proportion, one sample proportion, another sample could have another sample proportion. So the answer of this question is going to be, let's see which is read as correctly, and I think the C. The sample proportion p is random variables because the p varies from sample to sample. The variability is due to the fact that different people feel differently regarding their satisfaction. Yes, so different people feel differently, so different samples have different sample proportion. So sample proportion p is random variable. Part C. Describe the sampling distribution of p hat. Again, if you describe the sampling distribution of p hat, you got to say, is this sampling distribution of p hat is normal or not normal, and you satisfy the criteria. So the sample size is no more than 5% of the population size. Okay, so no more than 5% of the population size. I mean, sample size is less than 5% of the population size. You pick no more option here. And np1 minus p, let's find the value. What is n here? N is 100, p is 0.84, 1 minus 0.84. So if you simplify this, again p is 0.84 here, okay, you get this number 13.44. So rounded to 3 decimal places needed. So you can put 0 here if you like, but you don't have to. So it's going to be 13.44 is greater than 10. So these two criteria satisfied. We call the distribution if we had is approximately normal. Approximately normal with sigma p hat. Mu p hat is mean of the sampling distribution is same as p. Remember the formula, mu p hat is same as p, which is going to be 0.84, and the standard deviation of sampling distribution sigma p hat is going to be p 1 minus p divided by n, square root of that. And if you use the formula and put the value of p and n, okay, divided by 100, square root of that, and you simplify, you get this value 0.037 rounded to 3 decimal, 0.037. So the part C, describe means you say is normal or not normal, sampling distribution, sample proportion, and find mean of the sampling distribution and the standard deviation of the sampling distribution. Part C, part D. In the sample obtained in part A, which is 100, what's the probability that a proportion who are satisfied with the things going to their life exceed 0.86? So here I'm looking for probability of sample proportion exceed means greater than equals to 0.86. Again, here has to be p hat, because it says what's the proportion who satisfied exceed 0.86 from that sample which is obtained in part A. So we're looking for probability of p hat greater than equals to 0.86. So again, we use normal CDF as we did before, normal CDF. So first use lower bound. So we have a greater, that means the first number here, 0.86 is the lower bound. The upper bound is 10^99. We don't know because we don't know how far high it is. So mean gonna be 0.84. This is the mean, and the standard deviation gonna be 0.037. So if you use this in the calculator, you get probability of p hat greater than 0.86 is going to be 0.2927. Okay, again rounded to 4 decimal is needed. So this is the question D. Question E. Use the distribution in part C. Again, we use the distribution in part C. That means we use this is the mean, this is the standard deviation for this question. And would it be unusual for a survey of 100 people to reveal that 77 or fewer? So to check is this unusual or not, you got to find the probability. If probability is less than 5% or less than 0.05, we call this unusual. So pretty much in this question I'm looking for probability of x fewer than 77. Okay, remember that this is the number of individual with the given characteristics, but I got to change this x to proportion. Now notice that p hat equals to x over n, or 77 divided by 100 going to be 0.77. So this is same as probability of p hat less than equals to 0.77. So since you're looking for the probability less than 0.07, so use again normal CDF. So you are in less here, so lower bound going to be negative 10^99, upper bound going to be 0.77. The mean going to be from part C 0.84 here, and the standard deviation is going to be 0.037, close parenthesis. So again, input that in your calculator as you did before, and you get the probability is 0.0281, rounded to the 4 decimal places here. So the probability that 77 or fewer people in the sample are satisfied is, we get that 0.0281, which is unusual, I should say, which is unusual, because the probability is less than 5%. Okay, again notice that this is pretty much, if you look at this probability, 2.81%. so this is same as this percent, which is less than 5%. So this is unusual. The question is, would it be unusual for survey of 100 people or reveal that 77 or fewer people in the sample are satisfied with their life? Yes, it is. All right. Question 13. A researcher studying public opinion of proposed social security changes obtained a simple random sample of 25 adults American, they obtain 25 adult American, and asks whether they support or do not support the changes in Social Security. To say that the distribution of sample proportion of adults who responded S is approximately normal. So to say that is normal. So in other words, we want a sampling distribution of sample proportion to be normal. How many more adults? Look at the question. How many more adults? Looks like they sampled 25. That might not be enough. Might not be enough, right? So they ask you how many more you need to sample to make sampling distribution of sample proportion to be approximately normal. So pretty much we are looking for how many actually we need the sample size. There's two questions. Part A, 20% of all adult Americans support the changes. I do part A and part B is similar. Here part A, P equals to 0.20 because 20% of all adult Americans. So 20% represent population proportion because 20% represent percentage of all adult American. That's the P. So since I'm looking for how many adults we need actually, then they sample 25. That might not be enough. So, and I can find how many more I need. So let's find how many actually we need in this case. All right, so here the formula or rules, or we can see the criteria to be normal. NP 1 minus P has to be greater than 10 because this is the criteria for sampling distribution of sample proportion to be approximately normal. That's what we said. To say that distribution of the sample proportion of adults who responded as is approximately normal. So I'm going to use this criteria because this is the normal criteria. This is the normal criteria. Normal criteria. So I use N. I don't know what's N going to be. That's what I'm looking for. P 0.20. 1 minus 0.20 is greater than or equals to 10. So N 0.20. This is 0.80. Greater than or equals to 10. So 1 minus 0.20. So if I multiply this two, I get N. This gives you 0.20 times 0.80 going to be 0.16 greater than or equals to 10 divided by 0.16 divided by 0.16. So N is greater than equals to 62.5. So it's a round up to the nearest integer. So is 62.5 going to be 63 adults? So notice that nearest round up means doesn't matter if you have 62.1, still you have to do 63. That's called rounded up means. So actually we need 62.5. That means 62 adults, right? Actually we need 63 adults, right? But how many adults are sampled before? They sample what? 25. So that's not enough. So how many more I need is 63 minus 25. That gives you 38. So 38 more adults are needed. 38 more adults are needed. So 38 here. For the part B, you do exactly similar to this part A, and except you put P as 0.25 because 25% is a P here, and you'll get 29 answer for part B. Okay. Question number 14. That's the last question. Suppose that the candidate, suppose in a national election in which two candidates A and B are running for office, 52% of the population is in the favor of candidate A. So P here is 52% is 0.52 for A. Okay. A random sample of 1200 registered voters revealed that 588 are favor of candidate A. So out of 1200, X is going to be 588, who is favor A, by the way. Okay, and let's answer the part A through D. Part A. What is the variable of interest in the study? In this study, variable of interest is going to be whether the voters gonna favor the candidate A or not. So the answer must be B. Whether the voters favor the candidate A, that is the variable of interest. So again, you got to check the criteria. We should say sampling distribution is approximately normal. Because n is less than equals to 0.05 and you use that less than or equal to, and that's the first criteria. And np1 minus p, let's find the value. np1 minus p is how much? N is 1200, p is 0.52, 1 minus 0.52, and if you multiply this, you get 299.52. Again, you round it to 2 decimal places. This gives you 299.52. So np1 minus p equals to 299.52, and which is greater than or equals to obviously 10. So since these two criteria are satisfied, you can say that sampling distribution of sample proportion is approximately normal, and the mean of the sampling distribution of sample proportion is going to be same as p, which is 0.52, and the standard deviation sigma p hat is p1 minus p over n squared of that, or use the formula 0.52 as a p, 1 minus 0.52 divided by the sample size is 1200 and squared of that. So if you use the calculator, everything in the calculator, and round your answer to 4 decimal places for the standard deviation, it gives you 0.0144. That means 0.0144. All right. So part C. What's the probability that in a random sample of 1200 registered voters, 588 or fewer are in favor of E? Here I'm looking for probability. Here we are looking for probability fewer than 588 voters which favor the candidate. So here X is less than or equals to 588. So notice that here is a P probability. X is the number of individuals having characteristics less than or equals to 588. But now you got to change this X to P hat. So remember that P hat equals to X over N. So X is 588 divided by N is 1200. And that gives you 0.49. Okay, so this is 0.49. So technically we are looking for the probability of phi hat less than 0.49. Again, use normal CDF. So let me do this part C here. Probability of phi hat less than equals to 0.49 equals to normal CDF. So less means negative 10 to the power 99, comma 0.49. That's the upper bound, and mean is 0.52. We have it here. before. I'm going to see the mean here, 0.52. The standard deviation is 0.0144. 0.0144. Okay, and if you use that calculator using normal procedure, 0.0.0188, so which is going to be 0.0188 rounded to 4 decimal. Stockton said 4 decimal place. So that's the probability of probability of x less than equals to 588, or probability of p hat less than equals to 0.49, because 588 is same as 0.49 as a proportion. So part D, interpret the probability. So the answer should be D. And if 100 different random samples of 100 registered borders were obtained, right? So if you change this, the percentage is going to be 1.88%, which is about 2%. So out of 100, we'd expect to have a 588 or fewer borders favor the candidate. So that's the interpretation of this probability. But if you read other option, it say exactly that's not going to be true. It say at most, it's not going to be 2. It says about, or would you expect around. So it lists, that's not going to be true either. So answer should be D. So that's conclude this homework from section 8.2. Thank you for watching. Chiban again.